I welcome you all, and you are watching the series of 1000+ most expected and probable question in engineering for GATE exam this year. And I'm starting today the subject which is a very good subject and interesting subject, that is strength of material. अब इसमें ना बहुत कंसेप्चुअल सब्जेक्ट्स है स्ट्रेंथ ऑफ मटेरियल. मेरे को लगता है कि ज्यादा क्वेश्चन तुम सॉल्व करोगे उससे आपका कंसेप्ट इस पर्टिकुलर सब्जेक्ट्स के लिए विल बी क्लियर. तो इन द फर्स्ट वीडियो मैंने कुछ क्वेश्चंस एंड कुछ कंसेप्ट्स आई हैव आइडेंटिफाइड. All you have to do is you have to solve these 20 questions or 10 questions in 20 minutes and solve in such a way कि आप 7 करेक्ट करें और 0 इनकरेक्ट करें. मिनिमम रिक्वायरमेंट, मिनिमम एक्सपेक्टेशन इज दैट. अब इसमें इन दिस पर्टिकुलर वीडियो मैंने जो टॉपिक चूज किया है, दिस टॉपिक्स आर थर्मल स्ट्रेसेस एंड स्ट्रेन ड्यू टू द नॉट सेल्फ वेट, वो नेक्स्ट टॉपिक में है. स्ट्रेन ड्यू टू लोडिंग, एक्सटर्नल लोडिंग जब हम लगाते हैं, स्ट्रेस स्ट्रेन डायग्राम, सिंपल स्ट्रेस स्ट्रेन कंसेप्ट. सॉरी, मॉडुलस ऑफ इलास्टिसिटी, कितने टाइप के मॉडुलस होते हैं, पॉइजन रेशियो, बल्क मॉडुलस, पॉइजन दिस आपका मॉडुलस ऑफ रिजिडिटी, बल्क मॉडुलस एंड यंग्स मॉडुलस ऑफ इलास्टिसिटी, दैट कंसेप्ट. लेमीज थ्योरम विच इज अ लोड बेसिकली शेयरिंग थ्योरम. ट्रू स्ट्रेस स्ट्रेन वर्सेस इंजीनियरिंग स्ट्रेस स्ट्रेन कंसेप्ट. ये मैंने कुछ कंसेप्ट्स को जोड़ के 10 क्वेश्चंस बनाए हैं. सो लेट मी नाउ रीड these questions for you and you basically keep seeing these questions, keep solving these questions, आंसर लिखते जाएं and detailed solution of this, as you know, you will get on the Nimbus video, which the moment you solve this you refer the detailed solution for that. So let me read the questions here for you. There's a bar which is given in the diagram and you have to find out what is the thermal stress induced in this bar when I increase the temperature of this by 100 degree centigrade. There's a bar जिसमें मैं 100 डिग्री सेंटीग्रेड से टेम्परेचर इंक्रीज करता हूं. आपने ये बताना है कि कितनी थर्मल स्ट्रेस इंड्यूस होगी if the length is 100 millimeter and coefficient of thermal expansion is 10 raised to power minus 5 per degree centigrade, and you have to find out what is the stress induced, which is accurate up to 2 decimal points. This length, which is the gap, is 0.15 millimeter, the gap which is provided here. Is the first question clear? Let's go for second question now. For the arrangement or loading shown here, this is the bar which is made up of two materials, aluminum and steel, and at the section there is a 30 kilonewton load. Let me ask you, this 30 kilonewton is tensile or compressive or both? So there's a 30 kilonewton load acting at the section. This is aluminum, this is steel, both cross section area is equal. You can add one more information here. You can assume that the length of these two sections is equal. So length of aluminum and steel section is equal. Modulus of elasticity for steel and aluminum is given 140 gigapascal and 70 gigapascal. So you have to tell that what will be the strain in the aluminum part. What will be the strain induced in the aluminum part, that in 10 raised to minus 3 scale multiply by 10 raised to minus 3 scale pe you have to tell what is the strain basically induced in aluminum part. Is a clear question? Now let's go for third question. This is the third question. Now you are given 3 bars 1 2 3 which are of the same material having diameter d1 d2 d3 and lengths L1 L2 L3 such that lengths are equal, whereas diameter is d1 is more than d2 is more than d3. You have to arrange the bars in such order that you have to increase them in the increasing order of the strength. Which bar has maximum strength? 1 2 or 3 में से किस bar की strength is maximum? That is what you have to say. 1 is more strong or 2 is more strong, or which bar is strongest of all these? That is what you have to tell. So this is how you have to arrange these bars. Right? Let's go for next question. You have to calculate the change in length of bar 1 and change in length of bar 2 when these are subjected to the loads given. They are made up of the same material, and this load W is acting in Newton at the one edge. In this bar, this W is acting at the center. This W is acting at L by 2 meter length of the bar. The length of the bar is L. Here also length of the bar is L, but the load is acting at middle, load is acting at one of the edge. Area is same, material is the same. So you have to tell the ratio of the change in length of this and this, and the answer choices are given to you. I hope this question is clear. Let's go for next question now. A rod of mild steel is having circular cross section and it is subjected to load P, which is tensile. Due to this load, 50% there is a change in length and 20% there is change in the diameter of the rod. For this rod, you have to find out the ratio of bulk modulus to the modulus of rigidity. So you have to find the ratio of these two modulus for this particular rod. So he has given you change in length also, and he is given you change in the diameter also. So now this is the next question. There is a bar of 100 millimeter square area and it is subjected to a compressive load of 1.2 kilonewton, something like this. तो एक बार है जिसपे मैंने 1.2 किलोन्यूटन का कंप्रेसिव लोड लगा रखा है. अब मैं इसका टेम्परेचर बढ़ा देता हूं, मैं इस बार का टेम्परेचर बढ़ाता हूं, एंड दैट इंक्रीज इन टेम्परेचर इज बाय 10 डिग्री सेंटीग्रेड. You have to tell that what will be the stress induced in this bar. If there is no change in temperature, stress is very simple, load per unit area, but temperature is also changing. In changing, in fact, it is increasing. Now you have to tell what will be the stress in this. He has given you the coefficient of thermal expansion 10⁻⁵, and modulus of elasticity is also given for this material, and you have to tell what will be the value of this, what will be the stress induced in this particular bar. Okay, let's go for next question. This is a elastic bar of length L, cross section area A, and coefficient of thermal expansion is alpha. Young's modulus E is given to us and it is fixed at both ends. Now if the temperature of this bar is changed by temperature by T, you are to the stress which is induced is sigma, because if there is a rigidly fixed bar and temperature का मैं उसका बढ़ा दूं तो उसके अंदर stress induce हो जाता है, that is called thermal stress, which is given sigma. Now, keeping all the other parameters same, if I make the length of the bar double, if original length was not L but it is 2L, then what will be the stress induced in terms of sigma? Earlier it was sigma when length was L. Now if the length is 2L, what will be the stress induced? That is what you have to calculate. And this was previous year's question of GATE, that is mechanical engineering. And this is previous year's GATE question of civil engineering. Now read this question also. There is a metallic rod जिसकी length is given to us 500 millimeter, diameter is also given to us 50 millimeter, and it is subjected to tensile force of 100 kilonewton at both the ends. At the ends, right? It experiences increase in length by 0.5 millimeter and reduction in diameter by 0.015 millimeter. You have to tell what is the Poisson's ratio of the rod material. You have to tell what is the Poisson's ratio of the rod material. That is what we have to tell. So let's find out what is the Poisson's ratio in this particular case. Okay, now see this question. There is a rod A and B arrangement, something like this. Lengths are also given, and there is a load at 150 degree to B. The load is applied 150 kilonewton as this. You have to tell what is the ratio of extension of rod A to rod B. Extension of rod A and extension of rod B, what is the ratio of these two? So this concept is basically, if on the basis of P, what is the load in A and B, Lemmy's theorem you can use, or otherwise you can find out what is the load and then you can find out extension in these two. Now there is a bar of diameter 10 millimeter and it is subjected to load of 100 Newton, due to which it gets elongated by delta L. And diameter at this instant is 5 millimeter. You are to tell what is the true strain. So he has given you the original diameter and he has given you the final diameter when the load is 100 Newton. And you have to tell what is the true strain, not engineering, but true strain. You know the difference between engineering stress strain, true stress strain. Solve this question in 20 minutes and see your score. If it is 7 correct and 0 incorrect, it is good. So, and for detailed solution, please go to the link mentioned below and you go to the Nimbus learning channel which we have for this GATE questions and all, and you can see what is the solution, detailed solution for that. Fine. Thank you.